Hello everyone, welcome back to my YouTube channel. Today we are going to be looking at differentiation of sine x and cos x. Please, if you are new to this channel, kindly hit the subscribe button and don't forget to turn on the notification bell so that whenever new videos are uploaded, this bell, make sure it is turned on so that whenever I upload new content on this particular series, differential calculus, you will not be left out. You'll be the first to be notified once the content is uploaded. So you can get to me on WhatsApp using the number on the screen as you can see there. And also, once you watch this video, make sure you share it. Okay, once you like it, you share it to others so that they can also benefit from whatever you're going to benefit from this particular video. So as you can see, we are looking at differential calculus. Okay, differentiation of sine x and cos x, and this is done basically from the first principle. If it's your first time joining us, I am Temgum48 presenting this script. Enjoy your video. Our presentation proper, I will begin with the differentiation of the cosine function and the sine function. Okay, so to do this differentiation from first principle, as we are going to use, there are identities that are going to be useful. Okay, so the following identities are going to be useful. The very first one, we have the sine of A minus the sine of B. When you have the difference of two signs, it is equivalent to writing it in the form 2 cos A plus B divided by 2, then sine times sine A minus B divided by 2. So whenever you see this type of expression, you can simplify it using this relation, okay, as we are going to see earlier on. Now the second identity we're going to use is the cosine of A minus the cosine of B. So the first one is a difference of two sines. The second one is a difference of two cosines. The answer is negative 2 sine of A plus B divided by 2 times the sine of A minus B divided by 2. So take note of it, the negative sign. Many students forget it while writing it. Now also another identity that is not really useful here, but I have to highlight it because we will use it later on. We'll use it while differentiating the the tangent of x. So just keep this one, okay? That's the product of a sine function and a cosine function, this identity. I hope you are working with your notebook. Make sure you are taking down notes, because if not, you are wasting your time, okay? Like seriously. Now, tangent of theta is sine theta over cos theta, okay? That's another identity you need to know. This is like a recap of trigonometric identities that will be useful in this particular script. Going forward, there are certain limits that we need to know, and the first one is the limit as theta tends to 0 of sine theta over theta. This is standard limits. The answer is always 1. I will show you why it is 1 in this video, okay? Also, this other limit, the answer is also 1, and I will also show you why. And lastly, I want to show you how it is gotten. We know that when theta is small from trigonometry, right, there are three relations that are true. The very first one is the sine is approximately equals to what? Sine of theta is approximately equals to theta. If theta is a small angle, okay? Small means it is so small that you can even neglect it. You understand now? 0 point something, 0.0000, maybe 1. You understand? In as much as theta is small, sine of theta will always be replaced by theta. Okay? Take note of it because we'll use it. So coming back to this, to explain why this is this, the very first thing you have to know is that the limit of a constant is that constant. Just keep it like that. So now if theta is small, because theta is approaching 0, so theta is small now, so it means that sine of theta will be equal to what? Theta. Okay, so it means that we will have theta over theta. Theta over theta is 1. Okay, theta over theta is 1, and the limit of 1 is a constant now, it should be 1. Same thing here, sine theta, theta over theta will be what? 1. So the limit of 1 is 1. No matter to what value theta tends to, the limit is 1, in as much as theta is small. In as much as we have a constant there, no matter what we have here, it will always be 1. I mean, it will give you that constant. In this particular case, theta is small, that's why sine theta is replaced by theta. So that we'll have theta over theta, or theta over theta here, and the answer is 1. Okay, it is this answer that is 1. Then now the limit of that constant, which is 1, is that constant 1. Hope you are understanding. Then the very second identity is what? If theta is small, there is another one. We'll have the cosine of theta will be approximately equal to what? 1 minus theta squared divided by 2. You have to know this identity as well. Also, the tangent of theta will be also be approximately equal to what? Theta, when theta is small. So this is what we'll be using for this script. So while waiting on the next slide, kindly copy down everything, pause the video, memorize them, okay, because you need to know them offhand. Okay guys, we are beginning with the first part of our presentation, which is what? The differentiation of what? Sine of x. So to begin, we know that we are using by the first principle. Keep in mind that we are using by the first principle to differentiate sine of x. So before we begin, we have to let f of x to be sine x. These are functions to be differentiated, okay? These are functions. Then now, by first principle, we know that we have to look for the difference always. I've given you this so that you will not stress you. These 3 steps, they are very, very easy to memorize them. But rather cramming the formula, you might get confused at some point. But if you can memorize these 3 steps, then life will be easy. So we have to look for the difference of f of x plus delta x minus f of x. Then now from there, f of x plus delta x means in the expression of f of x, anywhere I see x, I replace it by what? X plus delta x. So now I've done that sine of what? X plus delta x, as you can see there. Sine of x plus delta x, you replace the s by x plus delta x. Then minus f of x. F of x is what? Sine x. This is it. Then now you see now that we have what? The difference of 2 sine functions. You see why I was giving you those identities at the beginning of the video, right? So we are going to utilize this our identity. I'll just write it here. We're going to utilize it here. So you see that I have sine a minus b is equals to this identity. Same thing here, I have a sine function minus another sine function. So it suits this form, so we're going to apply it. So everything, all you need to do is just to identify what is a and what is b. A is this first one, right? And b is this second angle. The first angle is x plus delta x, that's my a. Second angle is just x, which is my b. So apply it, I'll have 2, copy everything as you are seeing, and you just replace your a and b. A is what? X plus delta x plus this x divided by 2, as you can see in the formula, times sine of what? A minus b. A is what? X plus delta x, then minus b. B is what? X, which is this now, divided by 2. The next step, we have to simplify what we have here. X plus x is 2x, this is it. Then now I have delta x, it remains like that. Everything is divided by 2, this 2 remains the same. And then now the sine function comes down. What is inside this now? S minus s is what? 0. Okay, bull. So we are left with delta x divided by 2. Good. From there now, we go further to simplify this part. Since you have two terms on the numerator, as you can see, which are added, we can distribute this denominator to both terms at the numerator. So this one will be 2x divided by 2 and delta x divided by 2. If it's also addition, subtraction here, we can also do that. But if it is multiplication, no, don't do that. Okay? So we are doing it because it's addition here. So now, doing that, I'll have 2x divided by 2. The 2 counts, leaving out x. Delta x divided by 2 is what? Delta x on 2. That's the simplest form. Then copy down this sign. Delta x on 2. Okay? Nice one. So after having simplified, this is the simplest form of this difference. The next step now is to do what? To apply the ratio, right? This is a gradient, delta y on delta x. When you simplify delta y on delta x, we had this formula in the first video. Okay? In the first video, that's what we had. So all we need to do now is to divide this result by delta x. So doing that, I'll have, just copy everything that I have here. This is delta x. This is a difference, right? Then divide it by delta x. Then now the next thing we are going to do, a crucial step which is important in our video, we have to recognize this angle. I'm giving you reasons why we are doing it, so that it should not be that it's like a tradition, okay? But normally, if you follow it this way, it should be a tradition. Anybody that follows it like that is a tradition. But now, you have to know the reason why it is done. Look at this angle, delta x over 2. I have delta x here, and I want to have something like sine x divided by x. So since I have delta x over 2 as an angle here, should I not just also have delta x over 2 as the denominator? You see now, that will help you to evaluate a limit when you are applying the limit operator. So to do that, these 2 that you are seeing here, I don't want it to be here. How can I remove this 2 to come at the denominator? It's very simple. Multiply the numerator of this fraction by the reciprocal of 2. The numerator and the denominator of this fraction by the reciprocal of these 2. Remember, whenever you multiply a number by its reciprocal, it gives you 1. For instance, 1/3 times 3. The reciprocal of 3 is 1/3. So 1/3 times 3 is what? 1. Half of 2 is 1 now. That the reciprocal of 2. Remember, 2 is the same as 2 over 1. So when you take a reciprocal means you invert. It will now become 1 over 2. So 1 over 2 times 2 will give 1 here. Then now at the denominator will be what? Delta x times half, which is delta x over 2. So this will give us this result. Good. Then now, after having this is the simplest form, we now have to recall our formula. Okay, this is our limit. You now see the reason why I was dividing. If I have something like this, right? If I have something like this, you see why I was doing this. Remember, in the presentation, we were told that this thing is equal to 1. Since theta is a small angle, sine theta is exactly equal to what? Theta. Are you seeing that? It's theta now. Theta divided by theta is 1. So the limit of that 1, as theta tends to 0, is also 1, because 1 is a constant. So the limit of any constant it remains that constant. Nothing changes there. So that's the reason why I was doing this division. So that since when delta x will tend to 0, okay, I will use the fact that delta x is small. Dividing by a small angle what makes the angle even more smaller. So it means that this sine x will just give out the same thing. It will be approximately equal to delta x over 2. And delta x over 2 is exactly what we have at the denominator. Are you seeing that? Yes. So now that will just cancel out to give 1. Is that not simple and easy to look? Beautiful, right? So now, by definition, dy by dx, or the derivative, the differential coefficient of y with respect to x, which is our function, is equals to what? The limit as delta x tends to 0 of this gradient, delta y on delta x. And this expression that we have evaluated here, this is what we are calling the gradient. Remember, in the introductory part of this lesson, I emphasized on these things, right? I show you how this was gotten, so that it should not be a nightmare while we are using it. So even if you have not understood it, you go back to that video, that first video, go back there, watch it again, and learn from it. Okay, good. So now this is it. This my dy by dx is equals to that. All I need to do is to copy this thing and replace in what? Delta y on delta x. This expression, this answer that we had here, this delta y on delta x. This is a gradient now. Yes, change in y or change in x. So now we'll have the limit as delta x tends to 0 of this expression. Copy and paste. As you are seeing there, copy and paste. Then now, the beauty of the game now, while we were dividing by half, while we were dividing by multiplying the numerator and denominator by half, it was to create this ratio, this divided by this y. So we are going to separate these two parts. This is like multiplying a whole number times a certain fraction. So this first part times this ratio, this over this. You now see why I'm saying that once you have multiplication here like this, you cannot distribute the denominator to both terms. This is a single term even, okay? So it just remains there. We are just like arranging the term. It is not shift. It is not actually moving there. We are not altering the position of the term. It remains there as the only denominator, okay? Because the other one will be over 1. So look at it now. The beauty, how does it look? Since it's a product, I've treated it as a product. This product is this times this, right? One property of limit that I need to know is that the limit operator is distributive over multiplication. So when you have two functions multiply and you have to evaluate the limit of that expression, okay, or of that function, as x tends to a certain value, all you need to do is to do what? Calculate the individual limits and multiply them together. That is exactly what we are doing here. So we are distributing this property, this man, we are distributing it to this man and to the other part of the product. Okay, it's a product of two functions. This time this will give you back what you have here. So now you now see, are you seeing that when delta x is small, is approaching 0, it means it's small. It means that what? Delta x is small and you are dividing by 2. When you take a small number and divide by 2, it becomes smaller. Okay? I hope you understand. Take 0.1, divide it by 2. You get a smaller number. So since that overall expression there is smaller, it means that what? Sign of that expression will be exactly that angle you are seeing there, exactly like that. I hope you're understanding. So from there now, you have delta x on 2 divided by delta x on 2. Delta x on 2 on delta x on 2 is exactly the same thing. So it's 1. They'll cancel out each other. I hope you're understanding. Then from there now, the limits as delta x tends to 0 of 1 is a constant. It will give out that constant. Okay, now, so we are already clear with this part that the answer is 1. This limit here of this part, the answer is 1. There is no argument there. You understand? Okay, coming here now, as delta x tends to 0, as it approaches 0, it means that we just have to come and replace our 0 here. That's the last thing. Very simple like that. Okay, as it tends to 0, we replace delta x by 0 divided by 2. And this answer here is 1, so times 1. So you are having cos x plus 0. Cos x plus 0 is what? It's simply x, right? This x plus 0 is x. So now we will be left with what cos x now. So that's the final answer for the differentiation of what sine x. I hope you understand every step, very detailedly explained. And if you don't understand, feel free to highlight anything you don't understand, any step you need further explanation in the comments below or the comment section, or you can get to me on WhatsApp using the number on the screen at the beginning of the video. You can go back there and copy the number, text me to be added to my functional study group 101, where we will treat all sort of subjects there as you prepare for your examinations and university courses. Okay, good. So now, this is the first part of our presentation. We have seen how to differentiate sine of x. Now let's see how cosine of x is also differentiated. It is done in a similar manner. Okay, let's watch out. Alright guys, we are just from seeing how the sine function is differentiated from the first principle. So we are going to see now how the cosine function can also be differentiated from the first principle. They are like brothers and sisters. The answers, their approaches, they remain the same. There's a certain similarity. We will come to see that. So beginning, we're going to let f of x equals to what? Cos x. So we let f of x equals cos x. Then from there now, we follow the same procedure that we have been doing. Okay. The first step in differentiating from first principle is to evaluate the difference f of x. Okay, this difference f of x plus delta x minus f of x. F of x plus delta x means I come to my function f of x, and anywhere I see x in the cosine function, I replace it by x plus delta x. So doing that will give us this expression you are seeing here. So I'll be having what? Cos x plus delta x minus f of x. F of x is what? Cos x, so minus cos x. So going further, we have to recall again our famous identity that I presented in the first part of the presentation. Okay, we said that we are going to make use of this identity cos A minus cos B, which is equal to negative 2 sine A plus B divided by 2 times sine A minus B divided by 2. Okay, yeah. So the reason why we are recalling this identity is because here we have the difference of two cosine functions, right? Cosine of x plus delta x minus another cosine of x. So in this angle, the first angle here is A and the second angle is B. So all you need to do is to identify your A and your B, and you come now to this formula, this identity, and replace A and B respectively in their respective position. Okay, so doing that we'll have this expression. So you just copy everything the way I see it. What is A? A is x plus delta x, and what is B is just x divided by 2. Then we have sine, right? A minus B over 2. So I have this sine. A is what? X plus delta x minus my B. My B is x, so minus x. Everything is divided by 2. Hope you are understanding. Now, like I said, make sure you are solving alongside with a piece of paper or a book, more preferably, because if you are just watching, then you're wasting your time, because it will be very difficult for you to grab everything at once. It has been proven psychologically that when you write down something, it sticks. That's the first stage of storing information. Okay, the quantity of material you retain when you write it down is far greater than just hearing it. especially when it comes to this course, mathematics as a whole, this subject, mathematics as a whole. You don't study math by looking, you have to do calculation, you solve. Okay, coming here now, I have to simplify further. We know again x plus s is 2x. I have delta x divided by 2. S minus s is 0, so I have delta x over 2 here. You just simplify in their respective position. Then now everything other part remains the same. I will do exactly the same thing that we did here. See that the approach that you use for sine is similar to what you are using now in cosine. So they are like brothers, they are like siblings. Okay. 2x divided by 2 is x, delta x divided by 2 is delta x on 2, that's the simplest form. Then now the next step of our process is to get this ratio, okay? After look for the difference, after you've gotten the difference, the next step now is to look for this ratio. Delta x, that's change in y, remember this change in y at the numerator, this expression is change in y or change in x, okay? Okay, so I have delta y, this delta y on delta x equals to what? This expression divided by delta x, exactly that. So doing that, we have to just copy and paste. So copy this expression that I have here, put it here at the numerator, and the denominator remains delta x. Then now simplifying further, again, just like what we did, we have this expression here and there is delta x here. We have sine of delta x on 2. So I also want to have delta x on 2 at the denominator, so I'll multiply here by half and also at the denominator by half. So this one would change, this 2 change to 1, so we are just left with the negative sign there, and then now delta x over 2 here. Okay, then finally we now have to take the limits, because it's the simplest form. We now have to take a limit of this expression. Okay, the limit as delta x tends to 0 of the gradient delta y on delta x. Delta y on delta x is this expression here. You copy it and paste, copy and paste, don't change it. Very simple like that. Okay, then now we have to separate again like just what we did, so that this our limit. This one is a single fraction times this number here minus sine x plus delta x. Again, we have already seen that this limit is 1, so there is no argument with that again. All we need to do now is to focus on this part. As delta x tends to 0, we have to replace delta x by 0. That will give me what you are seeing there. Okay, it will give me this expression there. So finally, we'll see that we'll be left with what? Negative sine of x, because this is x plus 0, okay, times 1. Everything is times 1. So sine of x plus 0 is just sine of x. So I have negative sine x, okay. So when you differentiate the cosine function, the answer is negative sine x. Start storing it in your memory, because you will use this expression throughout your life as a student, whether you're doing what field of study, in as much as you are doing differential calculus and its application in different fields, in various fields. You must make use of it. I don't know how you want to escape, whether it's electricity or what, I don't know, whether it's modeling or statistics. You will make use of these expressions. Don't neglect anything here. Nothing is useless in mathematics. Nothing that was discovered is useless. Okay, there is a reason why it is documented, because of the enormous importance of it to nature. Okay, so you have to understand it. You have to understand it. There is no gambling here. So this is the end of our presentation for this video. Derivative of sine x and cos x. As a recap, When you differentiate a sine function, you get cosine of x. So you see how they are related like brothers. But now cosine say if you differentiate me, you can never get me back. You cannot get yourself back. So it means that the derivative of cosine is not exactly sine of x. You have to attach a negative sign there. Take note of it. Keep it like that in your head. That sine is so positive and cosine is so negative that he doesn't want to give back what he received. Sine gave birth to cosine, but cosine did not want to give birth to exactly sine. So cosine decided that no, you cannot be exact copy of I cannot give you back what you gave me. I have to put some negativity there. Take note of it. That is just the beauty of the game. Now, moving on to the next slide. I will stop here for now. So look at what is on the next slide. Alright guys, we have come to the end of our presentation. So what is coming up next is the differentiation of tan x. You will not want to miss this because it's full of drama. Cosine and sine, they were siblings, but tan is a little bit complicated. So you have to watch it, okay? Make sure you have subscribed and you have turned on the notification bell so that whenever I'm uploading the next video on tan x, you will be the first person to be notified by YouTube that this video has been uploaded. Go and watch and enjoy the fun, okay? Even though it's complex, the way I will present it, it will look like ABC. Yes, actually. If you follow my videos from now till the end, you will not cry again in mathematics. So stay tuned and see you in the next presentation. But before that, I would like to thank all of you for being up to this time. And one thing I want from you guys is to share this video, let it go to the highest domain of the public. Knowledge is power. Don't be selfish with knowledge. When you have received something freely, you should be able to give it out freely. That's why I'm presenting this video. You are not paying me for what I'm doing here, okay? It took me hours to design what you are seeing here as presentation, and it took me time and energy to sit down and be explaining it in such a way that you will understand. So all I need from you is support. Share the video, okay? Let it reach to the highest publicity it can reach. If you have friends abroad, you can give it to them. Share, let them watch and also enjoy what you have enjoyed. Nice day. Guys, before you go, I would like you to, drop some topics that you really need attention to in the comment section, okay? Topics that you think you are facing a lot of difficulties in understanding. I will look at it based on your demand and create videos for free for you, and that will help you understand the concepts at the lowest level possible. Yes, the lowest level possible. So see you guys in the next video that is coming up, differentiation of tan x. Bye bye.